Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet. In this we were doing binary tree, and the pattern was serialization or construction, basically construction pattern we were doing here. In the previous video, we have solved the question construct binary tree from pre-order and in-order traversal. In this video, we'll do the next question, which is from in-order and post-order traversal. Make sure you have watched the previous video because that is a prerequisite of this. Because if you have understood that problem, definitely this problem you can do on your own. So let's read the problem statement. The problem says we will be given the in-order and post-order traversal of any tree, and we have to construct the binary tree. Okay. Let's read the constraint. It says the number of, the length of in order is 3000. From 1 to 3000 means the number of nodes can go till 3000. Okay, and the obviously in order and pre-order length will be same, and it says they will have unique values. This condition is very important, remember, because to find the index, the element should be unique. Okay, so that's it. Okay. So if you had watched the previous video, we in the previous question we had given in order but pre-order traversal instead of post. Okay, so you know now in order helps. Once you find the root, it helps to decide what will be the left part and what will be the right part. Why? Because in order traversal says first you would have visited left, then you would have visited root, and then only you would have visited right. So if you find the root over there, so whatever comes before that, that will be my left part, and whatever comes after that, that will be my right part of the subtrees, right? But the main concern is in pre-order, the very first element has given us the root. Why? Because pre-order says root first, then left, and then right. But this is a post-order, and what post-order says? Post says first left, then right, and then only root. Means for sure if you are looking for root, then we have to go to the last index, correct? So it's very similar to the previous problem, of course. So first we'll get the root from with the help of last index, and once we have got the root, which is 3 over here, then we'll go in the in-order traversal, we'll get the index. Okay, once we got the index, then definitely whatever comes before it, that will be left part, and whatever comes after this, that will be my right part. Similar to the previous problem, but what line of code of change we have to do here is the main concern. If it is so similar, then this question has been so easy, right? Yes. So first though, obviously we'll get this root, correct? And if we have to look for the, obviously we have to look for the index in the in-order traversal. To look for the index of 3, there are two approaches. We have saw in the previous video also, look into the in-order, check for the value, because the values are unique. So wherever you have found the value, that will be the correct answer, and get that index. But that will take further O of n. So O of n, like for n number of nodes, you are taking n to find that value. That will make it O of n square. That will not be optimized code. So hence we decided to make a hash map, okay, where we have decided in the previous video. Okay, so we decided to make a hash map, and in the hash map we have decided to save the nodes with their indexes. Nodes with their indexes, node with their indexes, and so on. So now if we have to get the index for 3, we'll simply go in the map and we'll get the index for this in just O of 1 time complexity, right? So we'll get this. Okay. But the main concern is we got this. Okay. So we can make root like how we made in the previous problem. Root will be my 3 is nothing but from my post order with that post order index, post index. Okay. And next time post index we have to move behind, so we have to do minus. In the previous question we did plus because we were moving from left to right, but here we are moving from right to left, so we have to do minus. But after the root creation, what we did, we made root dot left and then we made root dot right, remember? Yes. Why? Because the next, like when we were doing pre-order, after 4, 9 was my left side node. But if you see this post order clearly, because you have arranged the nodes like this, left first, then right first, and then root. So for sure after this 3 root, whatever we will get, which is 20 cannot be my left root, correct? 20 will be my right side root. Can I say that? Yes, correct. Yes. So hence, because 20 is my right side root, okay, so instead of calling the root dot, instead of calling the function and saving it in root dot left first, we have to do root dot right first and then left. That's it. Only this much change. And we know now what what indexes means left and right value we have to send. Definitely from 0 till this index, like whatever comes before 3, that will go in my left part of subtree, and whatever comes after this index till last, that will be my right part of subtrees, correct? So what we'll do, first we'll make a hash map to store our elements indexes of type integer. Okay, let's call it map new hash map. And post index we have to initialize, correct? Post index will take care of every root from the post order traversals, post order list. Okay, now in the main function, whatever the given by the lead code, inside it we have to run for int I is equal to 0. We have to run in the entire in order. So I will go till in order dot length and I plus plus, correct? And now in this, what we have to do, in the map we have to put what value which is in order of I, and we have to put the index which is I. That's it. So this much code will help us to make the map, which will help us to find the index of every root in the in order in just over. Now in the main function, what we have to do, we have to return after calling, which build function will actually help us to make the entire tree, and will return a root. So that root which we'll get from the build function will return to the final call. So in the build function, what we have to send, now in order is not needed because in order was needed to get the indexes of the roots, but now the map will help us. So hence we just need to send the post order. So we'll send the post order, we'll send a left and we'll send a right index. Okay, and I hope you know why we are sending this left and right index. Okay, if no, then definitely again I'm saying please go and watch the first video. Okay, so in the build function, what we'll do, we'll get the post order which is of type integer array post order, correct? And we'll get the integer left and integer right. Okay, now what about the base condition? Because see, when we are calling the function recursively, so if we are traversing to the root or linked list, then we can say okay, keep moving until that node becomes null. But here the node is not there. We are going to create the nodes. So on what basis we are moving here? Obviously with the right and left indexes, correct? So there should be some stopping condition with the help of indexes. So when left is lesser than right, when left is somewhere here, right is somewhere here, then we can say yes, it's valid, because from in between this we have some nodes. Also when left is here and right is also here, so here also we can say yes, it is valid. When left and right pointing to the same node, same number, then we can say okay, at least there is a possibility to create one single node over there. Right? But when it crosses, then we can say okay, it's done. So the base condition will be if my left is greater than right, then we have to return. What we have to return, we'll see. Then our task was to make root. Root will be of type tree node. Yes. So tree node root is equal to new tree node. Now what will be the value of that node? That value will get, what was the post index? So post index will be starting from here instead of pre-order, because instead of 0, because in the pre-order traversal the first index says it is a root, but in post order the last index element says it is a root, correct? So hence from the post we have to read the last index value. So we'll write post order. From post order we have to read from with the help of post index, and we have to do minus minus for the next term. So earlier post index needs to be started from here, right? So here somewhere we'll write post index will be nothing but we can say in order or post order length minus 1. Why? Because both length will be same only, right? Now once we have created, definitely the post order index will come at 20, but first so we made root with 3. Now 20 will be root's left side or right side? Obviously right side, child, you saw. Okay, so hence we'll call root dot right, we'll call the same function build, that will return a root that will get attached to roots which is 3 right side, okay, which is 20. So now here also we have to send the same post order, but because we are going towards right side, listen it very carefully. Here we are first we have to find this index, and because we are going towards right side, so whatever this index will be, after that will be part of right side, correct? So first our task is to get that index before calling this, right? So before calling this, we'll get the index, let's call it in order, in index, okay, in index, and that we will get with the help of map, which is map dot get. Now we have the root, so with the root dot value we'll get that, okay? Or we could have simply given by post order last index, which is obviously root, so that's why we have given root dot value. Now whatever in index we have, which is for 3, which is 0, 1, 2 index, correct? So we have to send, because we are calling for the right side, so we have to send in index plus 1 till whatever right is. So in index plus 1 and whatever right is, which is right only. Now after this only we'll call for root dot left. We'll call the same build function with the same post order. Now this time the left will be left and the right will be in index minus 1. Why not in index? Because in index was supposed to be root. Now we are going towards left side. So that node, that index value cannot participate either in the left subtree or right subtree. So hence for the left side we have to start from the same left, which is 0 till 1 minus index. And for the right side we have to start with 1 plus that index plus 1 till the right index. Okay. So now we'll go towards this side. So now this side what will happen? Because we have moved, so next time 20 will become the root and we have to find the 20 index here. So from this, because in this call left was starting from here, so from this till here, so only 15 will participate in 20's left side and only 7 will participate in 20's right side. So this is how it will get created. And now after this we have to return root. We have to return root. Okay. So now when 27 and 15 will get created, 20 will return itself and that will get connected in 3's right side. And now only we'll go towards 3's left side, which is 4, 9. We will at that time will be somewhere here. Now 9 is the root, so 9 will get attached, but before getting attached 9 will get created first and 4 will get created first. 4 will return itself, then 4 will connect it to 9, 9 will return itself, then 9 will get connected to 3. This is how it will get created. Okay. So we will be actually creating the nodes from upward direction only, but the whole tree will get connected when we are returning back over there. Okay. So hence as we are going on every node, so time complexity will be O of n. Space complexity would have been O of height, which is log n, because of the recursive calls. But as we are using a map over here, HashMap, to reduce the time complexity to find the index in the inorder. Okay. So hence the space complexity which will be O of n because of the HashMap. So this is also the optimized code only, but definitely I hope you would have saw the previous video, which is creation of binary tree from inorder and preorder instead of this question. Means after watching that first video, then if you're coming here, then I'm fully sure that you would have understood both of these videos. Okay. So let's write this code in the editor. Okay. So here is the editor. Let's write the code together. First we'll make a HashMap, correct, of type integer. Why? Because we are saving basically number, integer value and their index. Yes. New HashMap. Now after this we have to initialize integer post index. Okay. Post index. Let's initialize here. Now in this we have to run in the entire inorder. So int I is equal to 0 till I less than inorder length, correct? In order dot length, now I plus plus. Now in the map we have to simply put the value which is in order of I, correct? And we have to put the index which is I. That's it. Now after coming outside we have to call the build function with the post order, because now the pre-order is not needed, right? Yes. So we'll send this post order, we'll send a left variable and a right variable. So basically left will be starting from 0 and right will be starting from, you can say, in order or post order length minus 1, correct? Yes. And we have to initialize this post index also starting from the last, because that will help us to find the root, correct? Done. Now let's make a private variable, return type will be tree node, because we will be returning root. Yes. And let's make a build function. In the build function we will be getting the integer array of post order, correct? Post order. Then we'll be getting integer left and integer right, correct? Now the first base condition key, if my left crosses right, then we have to return null. Why we have to return null? Because I'll show you. First we have to make the tree node root. And how we'll make the tree node root? New tree node. We have to put the value. So value will be from post order and index will be post index. That's it. Yes. And for the next time, minus minus. Okay. Now our task is to get that index from the in order. So int in index we'll get from the map, which is map dot get with the value of root, which is root dot value. Now once we get, we will call for root dot right side first, and then we'll call for root dot left side, correct? Left side. Okay. Now we'll make the same build function. Okay. Now we'll send the post order. Okay. But because we are calling for the right side, correct? So in the Inorder traversal, here if you see, here we got the index, correct? So for the right side, we have to send this index plus 1 till right, correct? So we have to send in index plus 1 till right, correct? Now we have to call for the right side, but here it will be left. Why it will be left? Because here if you see, for the left side, it will be from left side to in index minus 1, right? So in index minus 1, that's it. And after this, we have to return the root. That's it. Let's run the code. Okay, sorry, missed this. Okay, done. Now let's submit this code. So I hope you understood. This was the code in Java, and here is the code in C++ if you're from C++ background, and here is the code in Python if you're from Python background, with a similar approach. So I hope you would have submitted both the questions earlier with in-order and pre-order also, and this one with in-order and post-order also. If yes, then definitely you are eligible to go and mark the next question from this sheet. So that's it guys. If you really understood, please do let me know in the comment section that yes, submitted or understood, or if you have any doubt, that too also you can definitely let me know in the comment section. I'll definitely try to reply you all. And if you have liked the video, please hit the like button and subscribe the channel if not yet subscribed. And if you need any kind of guidance, I'll attach my social media links, and also I'll attach the sheet link if you don't have that, so that you will start your DSA journey with the pattern wise. That's it. Let's meet in another video with some more interesting questions, topics and patterns, and then keep learning. Take care of yourself and your family.